Morning to everyone. My name is Marco Guevara. I'm a professor of the ECAPMA in the Universidad Nacional Abierta a Distancia. This presentation is about the air quality modeling using the model MERRA version 2 from NASA. It's for the final exam of the course Air Quality Monitoring Networks Design. This is one of the two choices you have to develop this last part of the course. Any question about this topic and about what I will show you next, you can write to me to the email on the screen. This is a very easy way to proceed in order to use this data package from NASA and how can be implemented to design air quality monitoring networks, which is the main aim of our course. I will start very briefly describing the platform and how can you download the data from the website of NASA, and how can you use the analysis tools online to develop your own analysis plot, and how can this data be used by you to assist the design of the air quality monitoring networks in your area of influence and interest in your research and work. Okay, first of all, we will use our Internet Explorer to go into this website. It's called Giovanni. This website is an online platform built by NASA, in which they put the data online so you can choose your area and the data you want to download and to analyze, and based on that make a post-processing of the data. One very important aspect about the package you should consider for your development is called the MERRA 2 model, as I showed you before. Is MERRA version 2 data package. Is a package of results of simulation that NASA developed day by day, and the simulator they use is called GEOS5. So they run this simulator online all over the world. It's a global model. It's also fitted by the emissions inventory of every cities and countries and places around the world, and with different sources. It's located in a database in the US, so the model is constantly updated and fitted. And they run this simulation, and they publish the results each month in this platform. You will also see different other packages available online, but I suggest you to use this MERRA 2 model. So let's begin. First of all, you should recognize the difference between these options. These are different analysis options available for you. The one it's based in maps, and we will use this one. Is a time average map. It's a map that shows you a contour of your variable of interest with a time averaged result. If you want more information, you can click here in details, and you will be able to see the user manual of the platform and the different types of analysis you can run and that package you can download. And here at the top you will see the index, and if you go to Quick Start, you will see something like a brief summary of the steps you should follow to run a first simulation. Let's say simulation, but you only would download the result of the simulation is already run. Okay, once you have read this user guide, at least briefly, you can go back to the platform, and we are ready to start with the next part of the platform description. These are other kinds of analysis you can run. Maybe this one is very interesting, is area average differences, but we will use area average. Basically, area average is time series of a variable averaged in the area of your interest. So we will use these two good types of analysis in this video tutorial. To begin, we should first define our variables and what we are going to use for our analysis. If you go here to platform and instruments, you can see there is other menus here. The first one is discipline, so you can merge your data by different disciplines as water energy, cycles, oceanography, hydrology, whatever. Atmospheric chemistry, atmospheric dynamics will be very oriented to aerosols and atmospheric chemistry. But this is not the kind of merge we're going to use right now. In measurements, we have other kind of data which is sorted by variables, can be measured with different instruments, so you have packages, and this is what we are looking for. Here you will see different data sets, and inside this you will see there is many options. Here you have the MERRA model, which is the old one, but we shall use this MERRA 2 model. Once you click on it, the platform will show you the different variables you can choose from this package. And for each variable you have the name of the variable and this code name. I will talk to you about this in more detail in a few moments. The units in which the variable will be downloaded, the package. In here we choose MERRA 2 model, so all the variables will be located and indexed to this package. This is the time resolution, so there is monthly, hourly and daily temporal resolution. Monthly is for a brief study is pretty good. If you continue to looking, we will see the spatial resolution in degrees of latitude and longitude. You should remember that 111 kilometers corresponds to 1 degree, so here we have like 55 kilometers by 60 something kilometers, something like that. And we have the begin date and the end date of the whole package. The simulation had been run from 1980 to the last month of this year, 2018. So you have the all data you can choose to develop your analysis. Now we're going to talk a bit about this variable. So if you click on this variable, you should see this website with this other page in which they show you a brief summary of the variable. Okay, once we know how is the data located online for us, we can choose the variables we will use. So let's see how can we proceed here. Here we have meteorological and air quality variables. Both of them are very important for the kind of analysis we want to develop. Here you will see variables related with dust, with pollutants as black carbon, and for example this dust surface mass concentration. This is dust surface mass concentration for particulate matter, 2.5 microns. So let's use it. The unit is in kilograms per cubic meter with a monthly spatial resolution, so we will get the values by month. Let's see what other variables can we choose. There is many, as you can see, so you should be very carefully when you choose your variable. Okay, this is very interesting. 2 meter air quality, air temperature, sorry, which is a meteorological variable. It will be very interesting to see. And I'm looking for maybe some variable related with the wind speed, so we can analyze a bit more about this. Here we have surface wind speed. Oh yeah, so it's in meters per second, monthly in a spatial resolution. So we still have to define other two different aspects. The first one is the date. So we will choose the dates for a year beginning in 2017 in March to 2018 in April. Let's see, March, because the data for April is not uploaded by NASA already, so we should be careful with the range we choose. And now we have to choose our area. So here in this menu we have to choose the area for the data. Here is our country, which is Colombia, so we only have to choose the area of our interest. It's too close. Okay, let's see. So we are considering Colombia, Venezuela, Caribbean, Ocean, Panama, Ecuador, Peru, and part of Brazil. So we will see the results for this area, and we are using a time averaged map. Here the platform will show you the variables you have selected, and that's it. You should check everything it's okay, the type of analysis, the dates, the beginning and ending date for your analysis, and the area. So here you have the area. You can also put your coordinates here for the domain if you want to. This time it's qualitative, so we will use it that way. Now you go to upload data, and you wait for the platform to merge the data and prepare it for the download in your computer. So after this you will be able to see the once the data is downloaded in your computer, you will be able to see these contour maps with the data you choose, because which is the type of analysis called time average map. So you have many options here. You will see the 3 different variables you choose in a row. You have in this first plot the 2-meter air temperature. So this is the temperature, and this is the color bar for the temperature, which is in Kelvin. Here we have the PM 2.5 variable for dust, and here we have the wind speed. Remember, this is for a year between March 2017 and March 2018. Now we can make some post-processing here. This option of download here, you can download in these 3 formats: GeoTIFF, KMS for Google Maps, Google Earth, sorry, so you can download it and put it into Google Earth, or PNG for other uses. If you go here to downloads in the menu to the left, if you register yourself in the platform, which is for free, you also have the option to download the netcdf data file, so you can make a more rigorous post-processing if you have experience managing this kind of files, or you have tools to do so, as Panoply or whatever, Python codes. You can choose the tool you want to. This is not mandatory in this stage, of course, but maybe for someone interested in go deeply into the detail and topics, you can explore all these options you have. Let's back to plots. So here we'll do some post-processing. If you click here in layers and in options, you have several options here. The depth range, so you can deal with the data range. For example, here we should change this to 300 Kelvin. I recommend you to use the smoothing option, which is to see clearly the contour, because by default the platform will show you the discrete colors in the cells according to the spatial resolution of the data you have downloaded. So here with smoothing will be easier for you to analyze the data visually. You can also change your color bar. If you see here this button called view all palettes, so you can choose different. I like this one. Blue, yellow, red, divisions 12, source panoply. Yeah, it's very familiar. So if you click here in pre-plot, you will see how the maps change and how the contour is more it's easier to understand the plot. Yes, here you have the map. So you see it's a very accurate reading of the data. You see here the Andes mountains, and the tops are cold and the valleys are warmer. So you see here, for example, the valley of Magdalena and the plains between Colombia and Venezuela, also the Caribbean coast. It's quite warm, so you can see this pattern here. Okay, once you have analyzed this graphical data in terms of contour maps for your variables over your area of interest, you can click here in back to data selection and change your setup here. In this case we will maintain the same dates, the same year of analysis, but we will see the area average time series, and we will see what happened with these variables along this year, monthly, I mean month by month, and we will change our analysis area. Here we will be centered in here, just right here. So we change the domain, that's it. The coordinates will be updated here in this menu, and we will maintain these three variables selected, and we click in plot data. Once we do this, we again have to wait a bit for the data to load in our computer, and you'll see the time series of each variable along the year, month by month, with the variable averaged by the area we choose in the map. It's important to see. This will take a bit, and you have to be patient if your data set is so big, and if you choose a big area as well. For example, if you make an analysis of transatlantic protein transportations, you will have to wait more time for the data to be downloaded. In this case, it's a very small analysis, so we already have the data here. We have the units of each variable, which is consistent with the list of data we see in the data selection page. Here again, you can download the image here, and you can see the PNG image. Okay. Okay, so let's see. This is for dust. So you have the time series for dust, which is decreasing. Maybe some phenomenon related with the precipitations or seasonal behavior of the tropical meteorology is related with this decrease in the dust concentration in the area of our interest. By other hand, here we have the wind speed. So this is a pattern of wind speed. For some reason it's very low here in September, because it's quite interesting, because October is a season with a high wind. So we should analyze what's happening here. Maybe it's a phenomenon which is not well perceived by the simulators, or it's just about some mathematical issue, or I don't know. We should analyze and see what's going on here. But the rest of the year is a very nice average with more than 9 meters per second in wind speed, which is quite high, so that explains why it's a very interesting area for wind generation. And here's the temperature. Here we have the behavior of the temperature along the year, with a decrease here in February and March, which is quite a different area. If you remember, we have bi-seasonal behavior here in the tropical countries, particularly here in Colombia. We're really influenced by this pattern, so it's at least qualitatively accurate. Okay, we have finished this presentation, this brief introduction in the MERRA 2 model from NASA, sorry, for our use here in Colombia. This data can be implemented in analysis all over the world. Of course, you should be careful to use it properly, and there is a lot of possibilities, not only here for your local analysis and for the requirement of the course, but also for research and work in your professional life. So my invitation for you is to explore this alternative. As you can see, it's very easy to use. Once you're familiarized with the variables and how they can be downloaded and analyzed, you can pass through technical issues and go deep in the analysis and get very interesting products. And that's a very important part of our contribution with the environmental sciences and in general for our society and for our countries, because we are in a region of developing countries, and we have to be very interested in this kind of tools and this kind of approach for research. So that's it. Thank you so much for your attention. Remember, you can write to me to my email, which is in the screen right now, and I will be very glad to answer you. Thank you so much. Please remember, this is a presentation sponsored by the Universidad Nacional Abierta de Distancia, by the ECAPMA.